Alright, these are our notes for section 7.3 on 45, 45, 90 triangles. Okay, now there are two sections for 7.3. We're going to split it up into the two different types of triangles. This is the first day on 45, 45, 90 triangles. First thing I want to talk about is what a special right triangle is. Well, a special right triangle is a shortcut to the Pythagorean theorem. Okay, there are two types. The first one is 45, 45, 90, and the second one is a 30, 60, 90. Now they're both right triangles because one of the angles, and these numbers here refer to the angles of a triangle. So in this first one, there are three angles are a 45-degree angle, a 45-degree angle, and a 90-degree angle. The second one, the angles are 30, 60, and 90. So they're both right triangles. So you could use the Pythagorean theorem if you wanted, but I'm not going to give you all of the information. So it would be difficult to do that. So we use these shortcuts to figure out what the sides of the triangle would be. I've already told you what a 45, 45, 90 triangle is. They are the angles of a right triangle. Okay, so here's an example. We've got a right triangle here. It would be a 45 and a 45-degree triangle. 45, 45, and 90. Those would be the three angles. Now another way to think of it is that it's an isosceles right triangle. Okay, an isosceles right triangle. The reason it's isosceles is that two of your angles are congruent. They're both 45. So you could mark two of the sides congruent. The right angle would be your vertex angle, and then the other two angles would be your base angles. And since they're congruent, that makes it an isosceles triangle. So that's another way of thinking about it. It's an isosceles right triangle. We've got one more. We have a square here, and we're going to cut that square in half. Another way to think of this is that it is half of a square. Okay? Squares have four right angles in them, so that would be a right angle. And what this line does is it cuts the angles in half. Half of 90 would be 45. So that's 45, that's 45, this is 45, this is 45. This is also 90. And we've got a 45, 45, 90 triangle on this side. Same thing happens on the other side. So this would be an isosceles right triangle. Okay? That's another way to think of it. You will see that. So make sure that you realize half of a square is a 45, 45, 90 triangle. Now the big idea, the shortcut, is that the hypotenuse is the leg multiplied by root 2. Okay, so we're going to use variables in our diagram over here. We're going to say that the leg is x. Since one of the legs is x, the other leg has to be x also. And what our shortcut tells us is that if the leg is x, the hypotenuse is just x root 2. We take it, we put a root 2 on the end of it. It is that easy. Now there's two types of examples we're going to look at. I could give you the leg to start with, or I could give you the hypotenuse to start with. And they're solved differently. Okay? We're going to start with when you're given the leg. This is our first example. We've got a 45, 45, 90 triangle. The reason we know it's 45, 45, 90 is that it's a right triangle and it's isosceles. It's marked isosceles. Now it says that one of the legs is 5. One of the congruent sides is 5, which means the other side would also have to be 5. And then to find the hypotenuse, all we do is put a root 2 on the end of it. Okay, it's really 5 times root 2. It is that easy, so that's our missing value, 5 root 2. The next example, example 2. We've got 5 root 3 marked on both of the legs. Now the reason we know this is a 45, 45, 90 triangle is because the legs have the same value. It would make it an isosceles right triangle. Alright, so what we would do is we take the leg, which is 5 root 3, and we're going to multiply it by root 2. We're going to tack a root 2 on the end of it. Okay, we can't leave it like that. That's not an acceptable answer, so we have to multiply them together. There's really a 1 out in front of that root 2, so 5 times 1 is 5. Root 3 times root 2 is 6. There's the answer to our problem. 5 root 6. That's the hypotenuse. Pretty easy so far. The next one, we've got two variables to find. We have an x and a y. This is a little different, okay? It is marked 45, 45, 90. Notice your angles are marked 45, which means if one of the legs is 6 root 2, the other leg would need to be 6 root 2. So there's x. X is 6 root 2. Now to find y, we're going to multiply the leg by root 2. So 6 root 2 times root 2. I'm going to multiply that together. There's really a 1 out in front of that second root 2. So 6 times 1 is 6. Root 2 times root 2 is really root 4, but root 4 is a perfect square. That's really 2. So it's 6 times 2, and 6 times 2 is 12. So there's y. The value for y is 12. Make sure that you simplify it if you can. Not all of them will simplify. Example 2 didn't simplify. Root 6 didn't break down. But in this case, 6 root 2 times root 2, that will break down. It'll break down to 12, so make sure that you do that. Next set of examples, I'm going to give you the hypotenuse instead of the leg, and we do this a little differently. Okay? If we started with the leg and we wanted to find the hypotenuse, we multiplied. So if I start with the hypotenuse and we want to find the leg, we're going to do the opposite. The opposite of multiplication is division. So we're going to divide by root 2 on these, which means we're probably going to have to rationalize the denominator, which isn't hard. We've done it before, so we need to make sure that we do that. Let's start with this one. This will be our fourth example. Okay, we've got an isosceles right triangle. We know that because two sides are marked congruent. It's a right triangle. We're given the hypotenuse, and we just said if we've got the hypotenuse when we go to the leg, we're going to divide by root 2. So we have 12 over root 2. We can't have that. So we're going to rationalize it, which means we have to pick out our well-chosen one, and we get that from the denominator of our fraction. It needs to be the same thing over itself. So since we're dividing by root 2, we're going to multiply by root 2 over root 2. In the numerator, we get 12 root 2. In the denominator, we get square root of 4, because 2 times 2 is 4. 4 can be broken down, though. So we have 12 root 2 over square root of 4 is really 2, and those will reduce. 2 goes into 12 6 times. So the answer is 6 root 2. Now if you notice, we just did that in example 3. It's the opposite. Okay? Your hypotenuse was 12. We found 12 in example 3. And over here, I gave you the hypotenuse to be 12. That will happen a lot. Okay? So make sure, if you've seen it before, you can go ahead and skip most of the work. You should know what the answer should be. So use your notes to help you, because that will happen. So look at example 5. We're going to do the same thing. We have a 45, 45, 90 triangle. We know that because one of the angles is given us 45. This is 90 here in the middle, so that makes this one have to be 45 also. Both of the legs are x, and we're looking for x on this problem. Okay, so we're looking for both of the legs. We're going to do the same thing. We're starting with the hypotenuse. So we do 10 root 3 divided by root 2. Can't have that, so we're going to multiply by root 2 over root 2. Gives us 10 root 6 in our numerator. In our denominator, that's the same thing that happened in example 4, and that automatically broke down to 2. That's always going to happen. Okay, the denominator should be 2. Now they will cancel, because 2 and 10 are both even. 2 goes into 10 5 times, so our answer is 5 root 6. That's the answer for x. Okay? One more example, I told you would see this. It's half of a square. We've got a square here, it's cut in half. We are not going to worry about this part over here because it doesn't have the x on it. Okay, we're just worrying about where the x is. So we're only going to worry about the top half of that square. Example 6. Same thing happens here. Okay, you're given the hypotenuse, so we're going to divide by root 2. But we can't have root 2 in the bottom, so we're going to multiply by root 2 over root 2. That means we get 7 root 2 in our numerator. Again, the denominator, root 2 times root 2 is really root 4, but that's really 2. That doesn't reduce. This example does not reduce like 4 and 5 because 7's not even. So there's our answer. 7 root 2 over 2, and that would be x. Now those are your notes for section 4.3 on a 45, 45, 90 triangle. Make sure that you understand these examples, how to solve if given a leg to start with, and then how to solve if given the hypotenuse, when to multiply and when to divide, because that's really important.